Hello, everyone, and this is going to be a review of rotations and reflections that you've been learning about this week. Follow along just as an extra reinforcement of what we've been learning. So this week we started by talking about this idea of reflections. And so if we think about reflections, what I always tell my students is thinking about if you had words on your shirt and you look at your reflection in the mirror. What do those words look like? They are flipped, right? And so just like the words on your shirt are flipped and they're backwards, we're taking our shape and we're flipping it. As a reminder just of terms that we use in math class, our original figure is called the pre-image. And so we represent those with letters. So in this case, we would represent it with A, B, and C, and that is a triangle. Now our new shape after the transformation, so in this case, after the reflection, is called the image. And when we do that, our letters, A, B, and C, we put the primes with. They look like little apostrophes or little ones. And so that is A prime, B prime, and C prime is how we label this. And what's important with reflections is we make sure that the points are the same in the same distance from the line of reflection. So in this case, we're reflecting over the x-axis. So we're reflecting over this axis right here. And so we want to make sure that A is the same distance or the same number of blocks from the x-axis as A prime. So in this case, we have 4, and then A prime is 1, 2, 3, 4 points away as well. And we would see the same pattern if we look at B prime and C prime. So when you reflect, you want to be the same distance from that line of reflection. In this case, it's the x-axis. Now with those points, you'll remember that we use this rule. When we reflect over the x-axis, then our x stays the same, but our y is going to change signs. So if it is positive, it becomes negative. But if it is negative, it's going to become positive. If you remember this rule about distance, then this rule over here is going to come pretty naturally. Now, if we reflect over the x-axis, then the same idea holds of you want to be the same distance from that line of reflection. And so in this case, the line of reflection is our y-axis. Remember, we know this one's the y-axis because that y has that vertical line that goes straight up and down, right? And that letter y, that part goes straight up and down, just like our y-axis goes straight up and down. And so if we're flipping our pre-image, which in this case is our blue triangle, over to become our image, which is our red triangle, then we want to make sure it's the same distance. I know the blue is the pre-image because it doesn't have the apostrophes. It doesn't have those prime marks. And so if we look at A, we want to make sure it's the same distance from the y-axis. So it is 1, 2, 3, 4 away from the y-axis. And A prime is also 1, 2, 3, 4 away from the y-axis. We would see the same rule apply if we checked for B and for C. And so as we're reflecting, we can think about when we reflect over the y-axis, we change the sign of the x. So if the x was positive, it would become negative. And if it was negative, then it would become positive. So the x changes signs. The y will stay the same. So let's try an example. So we're trying to reflect this triangle ABC, over the x-axis, which is this line right here. And so let's think about that distance from the line of reflection. So A is 1, 2, 3, 4, 5, 6 blocks from the line of reflection. So we know that our A prime, or our new point, also needs to be 1, 2, 3, 4, 5, 6 away. So this will be our new point, and we label it as A prime. And so that point, if you look at the ordered pair, our x is at -4, and our y is at 6. And you'll notice that that rule holds true. The x stays as -4, and then the y changes from negative to positive. B, we can count, is 1, 2 away from that line of reflection, the x-axis. So we need to find 1, 2 away here to put our B prime. And our ordered pair for B prime is going to be, we always start with the x, remember, just like x comes before y in the alphabet, x comes before y in our ordered pair, so we have 4 and then 2. And if you look from B to B prime, 4 stays the same, our x stays the same, but our y changes. It changed from -2 to +2. And then our last one is this point C, which is 1, 2, 3, 4, 5, 6 away. So we want to make sure our C prime is 6 away as well. 1, 2, 3, 4, 5, 6. So this point is C prime. And C prime is at the point 4, 6. And now we can connect those points and make a triangle. And I'm actually going to erase for just a second some of these jumps right here so we can really see that shape and notice a few things about it. And so if we connect those points, hold on. If we connect those points, we're going to have a triangle still. But you'll notice, and my drawing is not very good, but you'll notice that this triangle, let me put a line right here. You'll notice that this triangle is equivalent to the other triangle. They're the same shape, they're the same size, but it's just been reflected. So from the pre-image, it's been flipped over upside down to become the image there. So that's reflecting over the x-axis. For this one, we're going to reflect over the y-axis. So let's start with point A, and let's find its distance from the line of reflection, which in this case is the y. So A is 1, 2, 3, 4, 5, 6 away. So we want it to be 6 away over here. 1, 2, 3, 4, 5, 6. So that point is A prime. Now be careful, you don't want it to be up too high or down too low. It needs to be in line with the original A. B was 1, 2 away, so B prime needs to be 2 away as well. So here's B prime. C is 1, 2, 3, 4, 5, 6 away. So we want it to be 6 away. So this is C prime. And so let's draw some lines to connect that so it's a little bit prettier than I could draw myself. And so if we look at this triangle, it is the exact same size and shape as our pre-image or our original triangle, but it has been flipped over. And let's check those ordered pairs. Let me get back to my pen tool. Let's check those ordered pairs to make sure it still follows our rule. So A prime was at 6, -3. B prime was at 2, -3. And then C prime is at 6 and 5. And so notice that your x is changing. So from -6, it becomes +6. From -2, it becomes +2. And from -6, it becomes +6. But your y's, that second number, stays the same. All right, and then the last thing we're going to talk about is the idea of rotation. And so rotation is probably the most complex. But the way that I like to think about it is I like to visualize where you're starting and where you're going. So you'll remember that we have two different ways that we can rotate. We can rotate clockwise or we can rotate counterclockwise. So if you remember, if we think about a clock goes from left to right, goes this way. If we're going counterclockwise, we're going the opposite direction. So let's think about just a point right here. If we're going clockwise, there's 3 different rotations that we can do. We can move to this quadrant down here. Would we move to this quadrant down here, we're going 90 degrees. If you move only one quadrant, that's 90 degrees. If you move 2 quadrants, that's 180 degrees. So if you say that someone did a 180, then that means that they've completely changed, right? And so just like that, when our point does a 180, it's completely changing to the opposite side of our graph. And then our last rotation that we would potentially do is going to be to go over here. This is starting to look like a banana. This is 270 degrees. So these are all clockwise. So black is clockwise. And so those are the rotations that we're thinking about. If we did 360 degrees, we would end up at the same point that we were at. Now I'm going to do, let's do it in this teal color. So if we use teal, that's going to be counterclockwise. So that's going the opposite way. And so if we think about our point, if we're going 90 degrees counterclockwise, it's the same as going 270 degrees clockwise. So if you see instructions either way, it's going to give you the same results. If you move 2 quadrants, that's 180 degrees counterclockwise. So no matter if you go clockwise or counterclockwise, 180 degrees always puts you in that opposite quadrant. So that one that's diagonal. And then our last one is 270 degrees. And so 270 degrees counterclockwise is the same as 90 degrees clockwise. I know this looks a little bit confusing, but if you can envision this, it's really going to help you, especially if you're not good at memorizing how the numbers work together. And so the reason why this is important is because it helps you understand what your solution needs to be. So if you need to look at it a little more, feel free to pause the video. And again, if you have any questions, you can ask myself or Mr. Sarah. But I'm going to go ahead and clear this off and explain the reason why this is important. So I'll switch back to black so it's a little bit easier to see. So let's say that we have a point here, and we know we want to rotate it 90 degrees clockwise. We know that it's going to end up in this quadrant down here. And so for this quadrant, we know our solution is going to have an answer where our x is positive and our y is negative. And so we can know that our solution, once we turn it down here, we're looking for these to be our signs. So let's go through what each of these quadrants mean. So that one is positive and negative. If we look at this quadrant up at the top, so the top right, we call this quadrant 1. This one is positive and positive. Over here, we have a negative and positive because our x is negative, our y is positive, and here we have a negative and a negative. So no matter where you're headed, you can figure out what the sign should be when you're rotating. Now, these are the rules. If you're going 90 degrees, then your X and your Y swap. If you're going 180 degrees, your X and your Y stay in the same order. And then if you're going 270 degrees, your X and your Y swap. So this applies to either clockwise or counterclockwise. So think about if it's going 90 or 270, then the X and the Y change positions. If it's going 180, it stays in the same position. Now, when you think about the signs, this is where I always get confused myself because I'm not very good at memorizing stuff. But if you're going counterclockwise, remember, if we go 90 degrees clockwise, that's the same as going 270 degrees counterclockwise. We're going 180, it doesn't matter which order you go in, if you go clockwise or counterclockwise. And then if you're going 270 degrees clockwise, that's the same as doing 90 degrees counterclockwise. And so those are the three types of transformations. But let's think about what's going to happen to our signs. So let's take this point, let's do a different one so it's a little bit more clear. Let's do a point right here. So the ordered pair for this point is going to be at 2, 4, because we put our X and then our Y. If we're trying to go 90 degrees clockwise, we know if we're going 90 degrees, we swap our X and our Y, right? Those flip. So the 4 goes in the place of the 2, and the 2 goes in the place of the 4. However, we need to think about this quadrant down here. The X is positive, but the Y needs to be negative. So the point would be 4, -2. And so really, this is how our sign would be. And if you're someone who likes to memorize, and this is really confusing over here, you can just remember if you're going 90 degrees clockwise or 270 counterclockwise, this is what you do. But if you're someone like me who likes to figure out the reasons behind things, then I think this is helpful. Now, if we take this point, remember this is our pre-image, we want to rotate it 180 degrees. Remember 180 is the opposite side of the graph, so diagonal. Remember, when you go 180 degrees, you do not swap the X and the Y. It stays as 2 and 4. But remember, we want our answer to be both a negative and a negative. So really, it's -2 and -4. So we changed both of the signs. So we have -2 and -4. And then our final rotation is 270 clockwise, which is the same as 90 degrees counterclockwise. Remember when you go 90 or 270, then you always swap your X and your Y. But we need to think about which one's going to be negative. So our first number is negative. So we have -4 and +2. And so we change the sign of that first number. And so I think Mr. Serra calls this the Harry Potter because he puts his zigzag through the ones that change signs. If that helps you memorize it, then you can. Or if it helps you to visualize how it is changing, you can do that as well. But that is really an overview on rotations. I think rotations are the hardest because there's a lot of rules that go along with them. So make sure that you're practicing rotations on your own. If you have any questions, then Mr. Serra and I are both here to help. And that is all that I have for you guys today. Thank you for watching.